So guys, this is another representation of different compilation stages, and my focuses were more about presenting the outcome of each compilation stage in terms of file extension. So first of all, we have the .c file, which contains basically your source code or C-based code. Then we have the preprocess stage, and the outcome of this preprocess stage will be the .i file, where we'll have all macros get expanded and so on. Now this .i file will be the input for the next stage, which is compilation stage. And the outcome of this one will be the .s file. So the .s file will have all instruction set basically that can be mapped to the C code, and where the processor can understand those instruction opcode and execute them. Of course, although this is considered a low-level language, but the processor cannot execute this file as it is. So we need actually to convert it to a raw sequence of 0 and 1s. And this is the job of the assembling stage. So it will take the .s file and create what is called the .o file or the object code. This is a pure presentation of zeros and 1 that are mapped actually to each instruction opcode. Finally, our project will be kind of big project, so we'll have multiple .c files, and the outcome of each one will be .o file. Therefore, to create a single binary or single image to be loaded into the target, we need another stage actually to reserve all undefined samples, then assemble all those object files, and of course finally map each instruction to valid address that is supported by the target. And this will be the job of the linking stage. Now the outcome of the linking stage will be single image, is called .elf, which extension actually .elf, or executable linkable file. This executable and linkable file will be the result of all those objects, so it will contain all this instruction presented by sequence of 0 and 1, plus some additional metadata. This metadata may consist of information like the date of the creation of this file, the host machine, and some debug information which are needed by the developer later to debug actually the .elf once it gets executed by the processor. This extra stage actually is not part of the compilation stages, but is part of actually, or may be part of the toolchain itself. It is the way actually we load this .elf into the target memory or system memory. This loader actually is quite important to be able to fit this .elf or the binary code into the target or memory system, and then actually it will trigger the execution of this target. So guys, this was an overview as well about different compilation stages from perspective of the outcome of each stage.